Welcome. In this lecture, we are going to see about medium optimization using Plackett Burman design. Why we need to optimize the medium? Media plays a vital role in influencing in cell metabolism, growth and product production. By optimizing the medium, we can enhance the product quality, product production and metabolic. We can also influence the metabolic pathways. Medium optimization allows for the efficient use of resources by systematically planning the experiments. Optimization is done by using design of experiments. In a design of experiments, we have several methods to design the experiments. Some of the experimental designs used to optimize a process are completely randomized design, randomized block designs, factorial designs, Latin square design and the split plot design. In completely randomized design, all experiments will have an equal chance of receiving any treatment. So it is suitable for simple experiments with homogeneous units. Next one is randomized block design. In this experiment, the experimental units or the variables are classified into groups, are grouped into groups which based upon certain characteristics of the experiment. Here the randomization will happen inside the blocks. So inside the blocks it reduces the variability. Next one is factorial design. Here this involves the simultaneous manipulation of multiple factors at different levels. So here when using factorial designs, we can study the interaction between different factors. Fourth one is Latin square design. It ensures each treatment appears exactly once in each column. So this is useful in the situation where extraneous variables could affect the outcome. Last one is split plot design. It combines the elements of both completely randomized and randomized block designs. Some of the terms we use in experimental design are independent variable, which can also be called as a factor. This is the variable that is manipulated by us in order to study the effect. So next one is dependent variable, which is received from the experiment. So it is measured as a result of the manipulation of the independent variable. Next one is controlled variable or constant. These variables are intentionally kept constant to prevent their influence in the experiment. Optimization techniques, we have several optimization techniques. So 5 of the optimization techniques are going to be discussed in this lecture. So first one is one factor at a time optimization. One factor at a time optimization, this is the traditional method. It is also called as one variable at a time optimization. Here only one variable is varied while the other variables are kept constant. So this is a very straightforward method and an easy method, but it does not capture the interaction of the interaction between the variables. Next one is Plackett Burman design. So this is a factorial type of design which specifically designed for screening and selecting the most influencing variables. So this is used to identify the factors that are influencing the experiment. So this is used when in the early stages of the optimization process. Next method is statistical experimental design. This design is used to systematically vary the factors to simultaneously study their optimization process. So the full factorial design, fractional factorial designs, response surface methodology comes under this experimental process. So this is suitable for larger experimentation. It will also consider the interaction between the factors. Next method is genetic algorithm. This method is inspired by the process of natural selection. So it will iteratively evolve the population based upon the results that is obtained as a in the previous experiments. So at this experiment, it will select the fittest individual to generate new solutions. And finally we have artificial neural network. This method is inspired by the structure of the human brain. So it can be employed to optimization. It can be also employed for optimization tasks. So they learn from the historical data of the previous experiments to predict the optimal condition in the further experiment. Before going into selection of materials by the Plackett Burman design, we need to study we need to know what is classical experimental design, how they have previously designed the experiments. So, to predict the factor which is influencing or not, initially traditionally what they have done is they will vary the factor by keeping the other factors constant, so that every possible interaction of the elements factors that is present in the experiment is studied. So, it is possible for smaller number of factors and smaller number of levels, but it is not possible when the factors are increasing. So, it is designed as a x power n experiments are required, where x is the number of levels and n is the number of factors. So, it is suitable for smaller number of variables, where 3 factors and 2 levels we have 2 power 3 8 experiments. In the same, if it is not suitable for 6 factors at 3 levels. So, when we are using 6 factors at 3 levels, we need to do 729 experiments to find out which is the factor most influencing. To avoid this issue, Plackett Burman design is developed. Plackett Burman design, it is a screening design or a factorial screening design. It is a fractional factorial. So, it will not completely randomize the experiment, but a smaller part of the factorial design is used. So, this is used to identify most significant factors among the larger number of factors. So, when larger number of variable is used, this method is used. So, based upon the principle of factorial design experiment, by varying 2 or more factors simultaneously, we can observe their combined effects in the response variable. So, this experiment, Plackett Burman design, uses a 2-level experiment. So, 2-level experiment design where the factors are given in a low level or a high levels. So, it only uses a fraction of full factorial design. So, hence it is called as fractional factorial designs. So, in Plackett Burman design, it allows the optimization of x minus 1 variables in x experiments. So, if we want to optimize 7 variables, we can do only 8 experiments in this method. Only by 8 experiments we can find out what are the factors in the 7 variables, we can identify that. And again, in this factorial design, Plackett Burman design, x must be a factor of 4. So, it should be a multiple of 4 around 8, 12, 16 like that. So, minimum number of variables to be optimized in this method should be 5. It should be greater than 5. The number of factors included in the experiment is determined, and if we do not have the required number of factors, we can add the other factors which will not influence the experiment as a dummy variables. Also, the factors that are not assigned to the factorial design can also be used as dummy variables. So, the Plackett Burman design table for 8 experiments is given here. So, this design has 7 variables, A, B, C, D, E, F and G, and we have 8 trials. So, in these 8 trials, we are taking factors E and G as a dummy variables. So, in this 8 designs, you can see in each trial A is high level in 4 trials. A is in high level in at least 4 trials, and it is in low level in 8 trials. So, when we are designing the factorial design, we need to ensure that the factor is equally distributed, that is, it is a high level in high and low level in equal number of experiments. So, likewise this table is designed. So, H, 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 L, H, L, L. So, each experiment, if you count B, here have 4 high and 4 low levels. If we count F, here we have 4 high and 4 low levels also in this experiment. So, by performing this in trial 1, A, B, C and E will be kept in a high levels, while D, F and G will be kept in low levels, and an experiment is performed, and the yield is recorded, whether the yield may be a biomass or a product concentration or anything that is obtained as a result of experiment. So, similarly, after performing this 8 experiments, we can record that yield. So, in each Plackett Burman design, each horizontal row represent a trial and each vertical column represent a high value or low value of one variable in all the trials. So, each horizontal row represent a trial and each vertical row represent a variable and at which level it is being performed. The effects of the dummy variable are also calculated in the same way in which the effects of the other variables are calculated. The effect of the dummy variable should be near to 0 or 0. When the effect of the dummy variable is not 0, we can assume that there is an error that is present in the experiment, whether it may be a handling error or an experimental error or an instrumental error. After the performing the experiment, we can record the yield by in this table. So the yield of the first trial, which consists A, B, C and E as a high variables, is 1.1. Yield of the second trial, which consists B, C, D and F in high levels, as 6.3. So similarly, we can record the experimental output of each experiment and we can go for the further analysis. During analyzing the Plackett Burman design, first step is to find out the sum of high variables and the sum of all low variables. So we will add the yield of experiments in which our variable is high and the sum of all the yields in which our experiment is low. So first step is to determine the sum of high and low responses. Second is to find out the effect of an independent variable in the response. So effect is given by average response of high value runs and average response of low value runs. So for this experiment, there are 4 trials in which the value is high and the 4 trials in which the value is low. So we can assume that sum of HA divided by sum of HA is divided by 4 minus sum of LA divided by 4. So the difference of average high and average low runs is given as effect. Third step is to find out the mean square of the factor. So the mean square of the factor of each variable can be calculated. So when we by using this formula, summation HA minus summation L the whole square divided by number of experiments. So in this case our number of experiments is 8, so hence we are using 8 as the number. So if we are using 12 experiments or 16 experiments, we can adjust this formula accordingly. Fourth step is to identify the error of the experiments. So the error of the experiments is determined, like I said earlier, the effect of the dummy variable should be 0. If the effect of the dummy variable is not 0, it represents an error. So we can find out the error by averaging the mean square of all the dummy variables. So in this experiment we have taken E and G as the dummy variables. So mean square of E plus mean square of G divided by 2 is our error. Last step is to find out the F test of the experiment. So F test is found out by taking the ratio of mean square of the factor divided by the error value, which we have found out in the previous experiment. So in this experiment I have prepared a table. So we have a sum of high values, sum of low values and the difference summation H minus L, which for this step is included for the easy calculations in the next steps. So effect is given, mean square and F test are provided. Here in this experiment I have 4 high level values for the factor A. When we are considering factor A, I have first trial, fourth trial, sixth trial and 7th trial for high factors. So if I add these, I will get the value of 3.9 as a result. Similarly, I can take the low level, the experiments in which the A is in low level, 6.3, 1.2, 5th trial and 8th trial. By adding these I will get the value of 14.9. So 14.9. So based upon this I will get the difference, and effect is calculated by summation H minus summation L divided by 4 in this experiment, and the mean square is calculated by summation H minus summation L the whole square divided by 8, and the F test value is calculated by the error value, mean square value divided by this error value. By this we will get these F test values. So in this F test values I have the highest response in the factor A, and the next highest is in factor B, and the next highest is in factor F. So other variables I have not calculated the F test for E and G, since these are dummy variables, and I have a F test value of 0 in the factor D. So what this F test value of 0 means is that this variable is not influencing the results. By analyzing this Plackett Burman design, I can conclude that I have 3 significant factors A, B and F, and a non-significant factor C, and a factor that is having no effect, that is with D. So by using this Plackett Burman design we can find out the most influencing and least influencing of the factors. Thank you.